Hello, and welcome to Math Matters. I'm Dr. Jameson, and today we're going to learn about a multiplication strategy to help you understand those tricky 9 facts. You'll need the following materials for today: your bag with the arrays that you created, some paper, something to write with, and scissors. I'll give you a minute to gather those materials. Welcome back. In the last session, I asked you to make arrays for these numbers. We're going to see what they look like and talk about some things that we are noticing. If you missed the last session, don't worry. You can make them as we go over them now. And just to remind you, after we finish making all of our arrays, we will be playing games with them. So make sure you keep them in a safe place. Or put them in a bag. For the product of 9, there are 2 different arrays. The first is a 1 by 9 or a 9 by 1 array. And the second is a 3 by 3 array. Your arrays should look similar to the one shown here. For the product of 18, there are 3 arrays. The first is a 1 by 18 or an 18 by 1. The second is a 2 by 9 or a 9 by 2. And the third one is a 3 by 6 or a 6 by 3 array. Your array should look like the ones shown on the screen here. For the product of 27, there are 2 arrays. You only needed to create the array 3 by 9 or 9 by 3. But there is also an array of 1 by 27 and 27 by 1. Your array should look similar to the one shown here, the 3 by 9 or 9 by 3. For the product of 36, you needed to create the 3 arrays seen here. They are a 3 by 12, a 4 by 9, and a 6 by 6. The 2 arrays for 36 that you did not need to create was the 1 by 36 and the 2 by 18, because we won't be using those. Your array should look similar to the ones on the screen. For the product of 45, you needed to create 1 array, a 5 by 9 or a 9 by 5. For the product of 45, there are 2 other arrays, a 1 by 45 and a 3 by 15. Your array should look similar to the one shown here. Now take a look at all of the arrays. What do you notice about them? Take a second and write down some things that you're noticing or share them out loud with a friend. Now, take a look at these numbers. What patterns do you notice? I bet you notice that all of these numbers have zeros in the ones place. Did you notice that these numbers go in increasing order from the top to the bottom? Did you notice that it's counting by tens? Yes, each time we get 10 more. Did you also notice that these are the numbers we say when counting by tens? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. That's what makes these multiples of 10. Now, take a look at these numbers. What patterns do you notice? Did you notice the tens place has the digits 1, 2, 3, 4, and so on? How about the ones place? 9, 8, 7, 6, 5, and so on. Did you notice that these numbers are also increasing from the top to the bottom? Did you notice that the numbers are increasing by 9? These are the multiples. These are the numbers we say when we are counting by nines, or we can call them the multiples of 9. What do you notice about the relationship between the two columns? Do you notice any patterns there? I'm noticing that each row I'm subtracting 1, then subtracting 2, then subtracting 3, then subtracting 4, and so on. This is another way you can represent an array. It is an array because it has equal rows and columns. This array has 3 rows, each with 10 in each row. We can also write this as 3 times 10, or 3 by 10. Now take a moment and get your 3 by 10 array out. What is 3 times 10? There are many strategies to figure out 3 times 10, which is 30. We can also write it as 3 times 10 equals 30. If 3 times 10 is 30, how can we use this figure to help us think about 3 times 9? We just need to take off one group of 3, and now our array becomes 3 times 9. When we take off the one group of 3, we have 30 minus 3, which is 27. Cover up one of the columns on your array to show the array 3 by 9. Let's try another one. Here is an array for 5 rows of 10. How can we use this information to figure out 5 times 9? If we know that 5 times 10 is 50, then we can figure out 5 times 9 by removing one group of 5. 50 take away one group of 5 is 45. Therefore, 5 times 9 is 45. So let's practice a little bit. How could you figure this out? You can think about the strategy we've been practicing, or use another one you know. Feel free to write your strategy down or explain it out loud. I'll give you a few moments to do this. Here's how you might have thought about it using the strategy that we've been practicing today. This strategy focuses on using our knowledge of 10. For 8 times 9, we think about 8 times 10, which is 80. Take off one group of 8 to get to 72. Therefore, 8 times 10, or 8 times 9, or 9 times 8, is 72. So 80 minus 8 equals 72. Remember, this is just one way to think about how we can solve this. What other ways do you think about it? So in today's episode of Math Matters, we learned about how we used our 10 facts to help with our 9 facts. Write about it or try to explain this strategy to someone at home. I'm Dr. Jameson. I hope you have a great day and keep on counting.